Alright, yesterday I think we did not, or I know we did not put the law of sines in right here, so I want you to go ahead and add this to where you were writing yesterday. Remember how the triangle is supposed to be labeled. Capital letters indicate angle measure, and the lowercase letters indicate side length. But that is, sorry, yawning. That is the law of sines. And then today, we're going to move on to the law of cosines, which again is used for non-right triangles. This is derived from the Pythagorean theorem, so you should be able to recognize some things about the Pythagorean theorem in the law of cosines. And as you're going through today's activity, keep that in mind that it's derived from the Pythagorean theorem. So that'll help you get through the work. You need information on 3 sides. Well, let me take that back. On 2 sides and the angle between them. No, I don't want to say it that way. 3 sides and 1 angle. You will know 3 values and have 1 missing. But the side length. Alright, so the law of cosine says c squared equals a squared plus b squared minus 2ab cosine c. And that should make more sense if I draw the triangle. So this is A, B, C, and this is A, B, C. In order for this to work, you've got to have the angle measure that's between these 2 sides. And you can call this triangle anything you want to make it match this formula. So what that means is if the angle that I was given is A, I can relabel this triangle and I can call that C, and I can call that C, and then I can change this to A, and I can change this to A, and now it'll fit my formula. That keeps you from having to learn 3 versions of this law. Just relabel the triangle so that the angle that you either have or that you're looking for is always C. Alright, now let's look at using the law of cosines. So if this is the law, c squared equals a squared plus b squared minus 2ab cosine c. Notice this is all multiplying right here. That's going to be relevant when you're using this formula. So let's say I know the measure of this angle is 20 degrees. And I know that this side is 8 and this side is trying to make something logical here. Let's just say 20. No, that won't be logical. That side is 7. Well, our formula says c squared. Well, we already know what c is. So I want to make this triangle match my formula. So I'm going to change the name of these sides and angles. I'm going to make this one A and this one A. I'm going to make that C and C. So now we can plug it into the formula where c squared is what we're looking for equals, alright, a squared, that's 7 squared, plus b squared is 8 squared, minus 2 times 7 times 8 cosine times cosine 20. Alright, now you just need to put this whole thing in the calculator. The whole line. And you get 7 squared plus 8 squared minus 2 times 7 times 8 cosine 20. You should get that. C squared equals 7.75. But that says C squared equals 7.75, not that C equals 7.75. So just like the Pythagorean theorem, you have to take the square root of that number. If you don't take the square root, your answer is going to be incorrect. So when I take the square root of that number, I get C is equal to 2.78. And that is your final answer. Don't forget to square root. Alright, now let's say for instance I knew the length of the sides of all 3 sides, and I needed to know an angle measure. What if I know that this is 8, and this is 7, and this is 3, and I want to know what the measure of angle C is? Or any of them. You can do this with any of them, as long as you line it up right. Alright, you'd have to solve this for cosine C. You have to subtract A and B squared from both sides, so you're going to end up with C squared minus A squared minus B squared. You're going to need to write this in your learning log equals negative 2AB cosine C. Okay? Let me just write it down. Equals negative 2AB cosine C. That's terrible, but that's okay. Alright, well, this is all multiplying. So to get negative 2AB away from the cosine C, you have to divide both sides by negative 2AB. So you end up with this divided by negative 2AB. Alright, so cosine C equals this. And if we're looking for angle measure, remember that means you have to use the inverse cosine or the inverse function. So the final formula for finding angle measure using the law of cosines is the inverse cosine of C squared minus A squared minus B squared all over negative 2AB. And you need to be real careful about putting this in the calculator. You really need to use the alpha y equals and use the fraction bar, because if you don't put this part in parentheses and you don't put this in the calculator correctly, you will get the wrong answer. So you need to use the fraction bar when you put this in the calculator. So let's plug it in and see how it works. So if we're trying to get, well, let's say not that we were going to get angle C. I want to find angle B. Well, my equation says C. So once again, I need to relabel. This is going to be C, and this is going to be C. So that's going to make this B, and this can be B. Now I'm going to go over here, erase a little bit of this, get it out of the way. Alright, so I'm going to say C equals the inverse cosine of C squared, so 8 squared minus 3 squared minus 7 squared divided by negative 2 times 3, I know that looks terrible, times 7. That's a square. Alright, and then again, I'm going to use the fraction bar. I'm going to put in inverse cosine, alpha y equals to get the fraction. On the top, I'm going to put 8 squared minus 3 squared minus 7 squared. And on the bottom, I'm going to put negative 2 times 3 times 7. Enter. And I'm going to find out that angle C is equal to about 98.21 degrees. And I could go back and I could relabel my triangle to make this actually be C. This would be A and B. That would be side C. And I could plug it back into the formula, find this angle, and find that angle the same way using the law of cosines. And I want you to make sure that you have both of these formulas written down in your learning log. This is law of cosines used to find side length. This is law of cosines used to find angle measure. And make sure that you know you can relabel the triangle to match the formula.